जय हिंद बच्चों। आज हम आप लोगों के साथ पास एक नए टॉपिक के साथ आए हैं। बहुत ही इंटरेस्टिंग टॉपिक है और टॉपिक का नाम हम आप लोगों से जानना चाहेंगे। सो व्हाट इज द टॉपिक? हमारे पास क्वाड्रेटिक इक्वेशन है एक्स स्क्वायर माइनस वन इक्वल्स टू जीरो। तो हम क्विकली इसका सॉल्यूशन निकाल लेते हैं। दिस इज एक्स माइनस वन इंटू एक्स प्लस वन इक्वल्स टू जीरो। सो आइदर x equals to 1 और x equals to minus 1। यहाँ पर बच्चों एक और क्वाड्रेटिक इक्वेशन मैं दे रहा हूँ आप लोगों को, तो प्लीज सॉल्व दिस क्वाड्रेटिक इक्वेशन। द क्वाड्रेटिक इक्वेशन इज x स्क्वायर प्लस 1 इक्वल्स टू 0। सो x स्क्वायर प्लस 1 इक्वल्स टू 0 अगर आपके पास है तो कैन यू फाइंड आउट द सॉल्यूशन फॉर दिस क्वाड्रेटिक इक्वेशन? This gives you x square equals to minus 1, and in the set of real numbers there is no number possible, no real number is possible whose square is minus 1. अब यहाँ पे जरूरत है, there is a need of new branch of number, and that new branch of number starts with this. So it is x equals to square root of minus 1. So we represent this number as iota. So this is I represented by I and called iota. This is called imaginary number. Imaginary number. Now let us take one more thing like minus 3. So what you can write down minus 3 as? Minus 3 can be written as root under 3 into root under minus 1. That is equals to root 3 iota. So what is next? Similarly, for any number like root under minus 4, you will write down it as 2 iota. Now, is it true to have like minus 3 root minus 4 is equals to root under minus 3 into minus 4 is equals to root 12? Is it okay? Is it correct? Just ponder on it. So we are doing it in another way. As you have seen, minus root 3 equals to root 3 iota. So I am writing this minus root 3 is as root 3 iota and minus root 4 as 2 iota. So I am going to get root 3 into 2 into iota square. So what is iota square? If you can see from here, the iota square is square of root under minus 1, and that gives you minus 1. So iota square, in place of iota square we substitute 2 root 3 into minus 1. So we are getting minus 2 root 3. In this case you have root under 12. And root 12 can be written as root under 2 into 3, that is 2 root 3. So are we getting the same answer? No. Your answer is no. We are not getting the same answer. So what should be the rule? We must have root a into b equals to root a into root b in 3 cases. First, when a and b both are positive. Second, when a is negative, b is positive. Third, when a is positive, b is negative. But this rule is not valid. It is not valid when a is negative and b is negative. In this case, this rule is not valid. So we have learned just now what is iota. We have learned when the root ab will be root under a into root under b. In 3 cases it is valid, in 1 case it is not valid. Now we will proceed further. Now come back to our beginning of the discussion. We have started from here. And we have learned that to find out the value of this quadratic equation, we need a new branch, and in that term, in उसके क्रम में हमने फाइंड आउट किया कि रूट अंडर माइनस 1 को हमें किसी एक स्पेशल नंबर या स्पेशल नाम से रिप्रेजेंट करना पड़ेगा, एंड दैट स्पेशल इज आयोटा. Now we learn about the different exponents of iota. If iota square is -1, what will be the iota cube, and what is iota raised to the power 4? So iota cube will be must be iota into iota square, and that will be equals to iota into -1, and that will be equals to minus iota. And iota raised to the power 4 may be written as iota square into iota square, and that is -1 into -1, that gives you +1. So if you find out iota raised to the power 5, so it will give you iota raised to the power 4 into iota raised to the power 1. So that will be equals to 1 into iota, that is equals to iota. So what we can observe here, and what I want you to observe, so iota raised to the power 6 can be written iota raised to the power 4 iota square, and that will be equals to 1 into -1, that is equals to -1. So the values iota raised to the power 1 is obviously equals to iota. Iota raised to the power 5 is equals to iota. Iota square is -1, and iota raised to the power 6 is -1. Iota raised to the power 7 is iota raised to the power 4 into iota raised to the power 3, that is 7 can be written as 4 plus 3. So it is 1 into minus iota, and that is equals to minus iota. Again you can see here iota cube and iota raised to the power 7 have same result. Now iota raised to the power 4 is iota raised to the power 8, sorry. Iota raised to the power 8 can be written as iota raised to the power 4 into iota raised to the power 4, and that gives you 1 into 1 equals to 1. So what you can observe here, iota raised to the power 1 have same value as iota raised to the power 5. Iota square will have same value as iota raised to the power 6. Iota cube have same value as iota raised to the power 7. Iota raised to the power 4 have same value as iota raised to the power 8. And this will proceed on and on. So you can find out that if you represent any the power of iota, so n can be written as 4k plus something. So 4k or 4k plus 1 or 4k plus 2, 4k plus 3. In all these cases, or 4k. The first case was 4k. So we have by unit division lemma, you have this possibility. If n is an integer, then n can be written as either 4k or 4k plus 1 or 4k plus 2 or 4k plus 3. So in all these cases, if you have n equals to 4k, in that case iota raised to the power n is equals to iota raised to the power 4k, and that will be equals to iota raised to the power 4 whole raised to the power k, and that is equals to 1 raised to the power k, and that gives you 1. Now come to next, what is iota raised to the power when n is equals to 4k plus 1. In this case iota raised to the power n will become iota raised to the power 4k plus 1. This can be written as iota raised to the power 4k into iota raised to the power 1. So iota raised to the power 4k have value 1, and this thing is 1 into iota, that gives you iota. Next one is iota raised to the power when n equals to 4k plus 2. Then iota raised to the power n can be written as iota raised to the power 4k plus 2, and this gives you iota raised to the power 4k into iota square. Iota raised to the power 4k you can find out here 1 into iota square, you have -1. So the final answer is -1. Now iota raised to the power n when n is equals to 4k plus 3. So it will be iota raised to the power 4k plus 3, and that gives you iota raised to the power 4k into iota cube, and that is equals to 1 into minus iota, and that is equals to minus iota. So whatever the integral exponent may be, and you have the answers of iota raised to the power anything as 1, iota, -1 and iota, minus iota. Only 4 values are there. So we have talked about the exponent of or power of iota. Now we proceed further. So I have taken an example iota raised to power 243. Iota raised to power 243 can be written as iota raised to the power 4 into 60 plus 3. And this further can be written as iota raised to power 4 whole raised to power 60 into iota cube. We have used few formulas, a raised to power m into m plus n first. So it becomes a raised to power m into a raised to power n, and then a raised to power m into n equals to a raised to power m whole power n. Now it becomes 1 and iota cube becomes minus iota, and your answer is minus iota. So you have one example in front of you. Now we study about what this gives this equation, basically the quadratic equation where the d is less than 0 gives the rise of the need of a new branch of number that is called complex number. So what is this? This is called imaginary number. So complex number in the form of a plus iota b is called complex number, where a and b are real numbers. Where a and b are real numbers. And here real part of z is a, imaginary part of z is b. So this is the introduction of the complex number, and hence our chapter is complex number and quadratic equation. So a complex number is a number in the form of a plus iota b, where a and b are real numbers. Real part of z is a, imaginary part of z is b. Now after introduction of complex number, we will proceed further for algebra of complex number. So in algebra of complex number, the first thing is addition of two complex numbers. How to add two complex numbers? So if you have z1 equals to a plus iota b, one complex number, and z2 is equals to c plus iota d, another complex number, then their sum z1 plus z2 can be given as a plus c plus iota times b plus d. That means it is the sum of real part and the sum of imaginary part. Now what properties does addition of two complex number follow? The first property is closure property. Closure property. What does we mean by closure property? Closure property means sum of any two complex number will be always a complex number. So the set of complex number is closed with respect to addition. Second property is commutative property. All you well know commutative. So what is commutative property? This sum of two complex number is always commutative. That means z1 plus z2 will be equals to z2 plus z1. Third is as usual associative property. For any three complex number, we have z1 plus z2 and then plus z3 is equals to z1 plus z2 plus z3. So it is independent of that. Now one most important thing, that is existence of identity element. Existence of identity element. So identity element is an element which can be added to any complex number and you will get the same complex number. So what should be the identity element? Please guess. So identity element or additive identity for complex number is 0 plus 0 iota. आप किसी भी कॉम्प्लेक्स नंबर a प्लस आयोटा b में अगर 0 प्लस 0 आयोटा को ऐड करते हैं तो रिजल्ट आपके पास अनचेंज्ड रहता है, वही कॉम्प्लेक्स नंबर आपको वापस मिलता है. So this means what? This means the 0 plus 0 iota is identity element. अब जब identity element exist करता है तो inverse भी exist करेगा. When identity element is there, inverse must be there. So additive inverse of a complex number z equals to a plus iota b is minus a minus iota b. For any complex number a plus iota b, minus a minus iota b is its inverse. Now, what is the difference of two complex number? How to evaluate the difference of two complex number? Though that can be evaluated in the same manner. If Z1 and Z2 are two complex number, then Z1 minus Z2 will be the difference of real parts and the difference of imaginary part. And you can say the difference of two complex number is not commutative, and other properties doesn't hold in it. Now come to the multiplication, that is product of two complex numbers. So the product of two complex number is similar to product of any two binomials. So what we can find out here, so I have taken the same two complex numbers Z1 and Z2. I am finding out their product, so it is a plus iota b multiplied with c plus iota d. So there is nothing new. You can multiply straightforward as you have done in binomials, product of binomials. So a into c is here, a into iota d, so iota ad, and iota b into c, so you have iota bc, and iota into iota, it is iota square bd. So we will now segregate the real part and imaginary parts. So it is AC plus AC, iota square is minus 1, so it is AC minus BD. We have used here iota square as minus 1. Now in these two numbers we can take iota as common, AD plus BC. So this is the result of product of two complex numbers. Now you can very minutely, if you check, so it is real, A is real part of Z1, C is real part of Z2, B is imaginary part of Z1, and D is imaginary part of Z2. So it is real minus imaginary. So real Z1 into real Z2 minus imaginary Z1 into imaginary Z2. So real, imaginary, it will form the real part of product of complex number. Now come to the imaginary part of this. So you have real part into imaginary part. Real part of first, imaginary part of second, and B is imaginary part of first, C is real part of second. So it is real imaginary, real part of Z1, imaginary part of Z2 plus real part of Z2 into imaginary part of Z1. So what we understand by this, so real into real gives you real, imaginary into imaginary gives you real, real into imaginary gives you imaginary, imaginary into real gives you imaginary. So just like you can connect it to the product of signs, plus into plus is plus, minus into minus is also plus, and plus into minus is minus, minus into plus is minus. It can be correlated with that to memorize this. So now we proceed further. The properties of multiplication of two complex number. First one is closure. Of course, it is closed with respect to multiplication of two complex number. That means product of any two complex number is always a complex number. Next is commutative. Yes, it is commutative. That means Z1 into Z2 will have same result as Z2 into Z1. Next is associative. So is it associative? Yes, it is associative. You can check it that if you multiply Z1 with Z2 and that result is multiplied with Z3, or you multiply first Z2 and Z3 and the result is multiplied with Z1, you have the same result. Next one is distributive property. Yes, it is distributive over addition. So Z1 and Z2 and Z3, if we have three complex numbers, then Z1 into Z2 plus Z3 gives you Z1 Z2 plus Z1 Z3. Now after distributive property, we have to go for existence of identity element. Does the identity element exist? Yes, identity element for multiplication exists. What is identity element? So identity element for the complex number, for the multiplication of complex number, please think on it. What should be the identity element? It is 1 plus 0 iota. Why it is identity element? Because when you multiply any complex number with this number, you are going to get the same result. It is, the number remains unchanged. So that's why this number is identity element. If you have existence for existence of identity element, now we will talk about existence of inverse. As identity element exists, so inverse will exist. So does the existence of a multiplicative inverse for a plus iota b is there? Yes, it is there. If for any a plus iota b, the number a upon a square plus b square minus iota b upon a square plus b square is the multiplicative inverse. Why it is multiplicative inverse? Let us check it. For the complex number a plus iota b, we are going to multiply it with this complex number, and we are going to find out whether it is its inverse or not. So after multiplication, you are going to get this real into real a square by a square plus b square, and imaginary into imaginary first, minus imaginary into imaginary. So it is minus b square upon a square plus b square, and then real into imaginary, that is a into, you have minus iota ab upon a square plus b square, and then imaginary into real, that is plus iota ab upon a square plus b square. So what we are going to get, we are this a square minus into minus plus a square plus b square upon a square plus b square, and this term gets cancelled. So it, subtraction, after subtraction it will get 0 iota, and this after division I am going to get 1 plus 0 iota. So आप देख सकते हैं कि इन दो कॉम्प्लेक्स नंबर्स को मल्टीप्लाई करके आपके पास एक आइडेंटिटी एलिमेंट आ गई. तो फॉर एनी कॉम्प्लेक्स नंबर a plus iota b, this is its multiplicative inverse, provided a square plus b square is non-zero. That means it the complex number a should not have a square plus b square equals to 0. So that is the condition. Now proceed we go further. So we define something about the complex number, some parts of complex number. The first thing is modulus of complex number. What is modulus of complex number? Modulus of complex number is the complex number a plus iota b is mod of, represented by mod of z, and is given by square root, positive square root of under root a square plus b square. It is always positive, it will never negative. And next thing we going to define is conjugate of a complex number. What is conjugate of a complex number? Conjugate of complex number z equals to a plus iota b is represented by z bar. So this is the notation by which we represent conjugate of a complex number, and it is given by a minus iota b. Only the sign of imaginary part will change. So for example, if somebody asks to find out the modulus and conjugate of a complex number minus 1 plus 3 iota, so we have to evaluate the modulus of this complex number. So then mod of z will be square root of minus 1 square plus 3 square, that gives you a square root of 10. So this is modulus of z. And what is conjugate of z? Conjugate of z is minus 1 minus 3 iota. Only imaginary part will change its sign. Now some properties of modulus and conjugate of a complex number. If you you have product of two complex numbers and their modulus will be equals to z1 mod into z2 mod. Then if you have a division of two complex numbers z1 by z2 whole mod, this will be equals to z1 mod upon z2 mod. Obviously z2 mod should not be equals to 0. And some properties about conjugate. If you have product of z1 into z2 whole conjugate, so it is z1 conjugate into z2 conjugate. If you have z1 plus z2 whole conjugate, so it will be equals to z1 conjugate plus z2 conjugate. If you have z1 minus z2 whole conjugate, it will be equals to z1 conjugate minus z2 conjugate. You can verify them easily by taking some examples. And z1 divided by z2 conjugate whole conjugate will be equals to z1 conjugate divided by z2 conjugate. Again the same condition is here, mod of this z2 conjugate should not equals to 0. One more property and very important thing is z into z conjugate, that means a plus iota b into a minus iota b will give you what? You can apply identity as well. All the identities we have learned in the previous classes will be valid for the complex number. So you can a plus iota b into a minus iota b can be written as a square minus iota square b square. That is a plus b into a minus b, a square minus b square. What is iota square? Iota square is minus 1. So minus minus it becomes plus. We are using iota square equals to minus 1. What is a square plus b square? We have just learned modulus of z is under root a square plus b square. So it will be equals to mod of z square. So it is very important property. Z into conjugate of z is equals to mod z square. So you can see all these properties, and we come back with some examples and some other thing about complex number. Till then, thank you and bye bye. Have a nice day. You can ask your doubts in the comment section. आप अपने डाउट्स को कमेंट सेक्शन में पूछ सकते हैं. जय हिंद बच्चों, स्वस्थ रहिए, मस्त रहिए.